Hello everyone, welcome back to WE Academy. So in today's video, let's continue the model question paper of Introduction to Electrical Engineering. For Model A 3, question number 6. Until Model A 3, question number 5 videos I uploaded in my YouTube channel. Playlist name is Basic Electrical. Kindly go through that, it will definitely help you for the examination. So without wasting time, let's move on to the question paper. Uh, Just observe Model 3, question number 6. Explain the various methods used to control the speed of DC series motor. Parallel, you can explain the various methods used to control the speed of DC shunt motor. Any one speed control you can expect in the examination. So for this DC series motor, you can see there are two main types in DC series motor speed control. One is flux control method. In that again we have a subparts field diverter method, armature diverter method, and also you'll be having tapping control method and a parallel combination of series field. And the second main method is armature voltage control method. Also, you can call this as rheostatic control method. Okay, so now just see what and all you have tried in the examination. For the flux control method, there are four different parts again. One is field diverter method. For DC series motor, you can observe the word itself says a field diverter method. For DC series motor, if the rheostat or variable resistance, if the rheostat or variable resistor which is connected Rx, which is connected parallel to series field winding, so that this variable resistance or rheostat you can call as diverter. Okay. So what happens if you are connecting a rheostat which is parallel to RAC, the current flowing through the field winding that will be diverted. A few amount of current that flows through Rx, so that current flows to the RAC is going to decreases. That is, ISC is going to decreases. Whereas you know that ISC is directly proportional to flux, so that flux that produced in a series field winding is going to decreases, and we know that speed is inversely proportional to flux, so that by decreasing the value of flux, we can control the speed of DC series motor beyond the rated value or else above the rated speed of DC series motor. You can control. So in general, you just have to remember three main points. The first point is you're connecting a rheostat or variable resistance which is parallel to the series field winding. So that variable resistor you can call it as diverter. And second point, because of that diverter, the amount of current that flows to the RAC will be going to decreases. So that flux is going to decrease, speed of DC series motor is going to increases, so that by decreasing the value of flux produced in a field winding, we can control the speed of DC series motor beyond the rated value or else above the rated value. Similarly, one more method is armature voltage or else armature diverter method. The word itself says armature diverter method. In case of field diverter method, a rheostat which is connecting parallel to RAC, but in case of armature diverter method, a rheostat will be connecting parallel or shunted across armature. So that is called armature diverter. So you can see this method that will be used for the motor which required only constant load torque, so that an armature of the motor, you can see an armature of the motor which is shunted with an external rheostat or external variable resistance Rx. So this resistance Rx is called armature diverter. So what happen again? The current that will be current flowing through the armature which is diverted with the help of this Rx. So that current flowing through the armature is going to decreases, but current flowing through the field winding, that is ISC, is going to increases again. So by increasing this value of current, a flux is going to increases. If the flux increases, you know that speed is inversely proportional to flux, so that speed is going to decrease. The speed that will be going to decrease. So by increasing the value of flux, you can control the speed of DC motor below the rated speed value. Okay, so you can see these points, the same thing, an amount of current that any amount of current, that is armature current, can be diverted through the diverter. So due to this, what happen? Armature current will be reduces. If armature current reduces, field current will be going to increase, so that flux is going to increase, so that, but current through the series field winding increases, so flux increases, so speed of the DC series motor reduces, so that this method is used to control the speed below the normal speed or else below the rated speed. And another method is tapped field control method. You are making a field winding of DC series motor by doing a different, or else by dividing the number of taps, so that a field coil is tapped dividing number of turns. So this we can select, then what we can do, we can select the different values of flux by selecting the different number of turns. So if the number of turn is going to increases, the voltage across the field winding is going to increase, so that voltage across armature is going to decreases, speed of the DC series motor will be going to decrease. So like that, you can control the speed of DC series motor. So these are not so important, but you just have to write some statement regarding this. Main focus on field diverter method and armature diverter method. Similarly, the fourth type for flux control method is paralleling field coils. So paralleling field coil is nothing but, so we'll be connecting, in this method what you are doing, so we'll be connecting a field windings, we'll be dividing that field windings and connecting in a parallel. The field windings which are connected in parallel, what happen? So again, the current will be dividing. If the current is dividing, means flux dividing, so that current is reducing in a field winding, so that you can control the speed of DC series motor by paralleling field coils. So these four are comes under flux control method. So the first one is field diverter method by connecting rheostat in parallel to the RSC, and armature diverter method by connecting the rheostat parallel to the armature, then tapping the field windings, then paralleling the field coils. We can control the speed of DC series motor. Similarly, the second main type is armature voltage control method, or else you can also call this as rheostatic control. Rheostatic control or armature voltage control method. You should know the alternative names. So armature voltage control method is nothing but what? So in this method, again, you are using one rheostat or else variable resistance. So that will be connected in series with a motor circuit. You can ask me what is motor circuit here. So the motor circuit is nothing but DC series motor. You can see the circuit diagram. So here, this is a motor circuit. This part will be motor circuit. You are connecting one rheostat in series with this motor circuit. What happened? Then there will be a drop across this Rx. That is nothing but IL into Rx drop will be produced at resistor or rheostat. So because of this voltage drop, what happened? Voltage across armature is going to reduces. If the voltage across armature is decreases, as we all know, the armature voltage is directly proportional to the speed, so that speed is going to decreases. By connecting additional rheostat in series with the motor circuit, we can control the speed of DC series motor below the rated speed. So that what happens, if the voltage reduces, speed is going to decrease. So here you can control the speed below the rated speed of DC motor. Okay, so these all you have to write in the examination for 8 marks. Okay, so one is a flux control method and armature voltage control method. Flux control method only, what you are doing? So there you are doing 4 different main types again. One is a field diverter, armature diverter, then tapping field coils, then paralleling field coils. And second one is armature voltage control measure. So this arrangement, the circuit diagrams will be having the weightage of marks, so that don't draw a wrong circuit diagram. If the circuit diagram is wrong, explanation is right, you'll get 0 marks in the examination. Okay, so look into the next question. They asked a problem for 8 marks again. So it is very easy problem. You just have to understand the numerical before solving. So this problem which has a 4-pole DC shunt motor, so that they mentioned the type of DC motor, that is 4-pole. So P is 4. Give me a second. So P they are given, P is 4 they are given. Then what? It is a shunt DC motor. So you need to draw the circuit diagram of shunt DC motor. So a shunt field winding which is connected parallel to the armature winding of DC motor. 1 second. So shunt DC motor, a field winding which is connected parallel to the armature of DC motor across voltage source. You can call this as DC shunt motor across voltage source. So it has a supply voltage V. Now you read the problem. A 4-pole DC shunt motor, P they are given, P is 4. Then DC shunt motor, so which takes current from 250 volts, that is V they are given. From supply it is taking current, so that line current. So I line they are given, that is 25 amperes, and this current divided as one current that flows through armature called as armature current, another current that flows through shunt field winding called as ISH, and the given I line. So I line value is 25 amperes. And armature and field resistances they are given. RA they are given. RA is 0.5 ohm and RSH is 125 ohm. They are only given. And it is a wave wound. Remember, wave wound. So condition for wave wound is a number of parallel path A equals to 2 always in case of wave wound. And it has a 30 slots 30, and conductors per slot they are given 10, so that you can get total number of conductors Z equals to slots into conductors per slots. That's nothing but 30 into 10, you can get 300 conductors you have. Then they are given flux per pole, phi equals 0.02 Weber they are given. They asked you to calculate speed of DC shunt motor. N you have to find. To find N, use back EMF equation, that is EB is given by phi Z NP by 60A. EB is given by phi Z NP divided by 60A. Everything they are given, but you don't know the value of EB here. So you need to find the value of EB. To find EB, so they are given DC shunt motor, so that EB is given by V minus IA RA. So if you want to find EB, you should know the value of voltage V, armature current, and armature resistance. So here they are given the value of voltage and RA, but IA they are not given. But you need to find the value of IA. To find IA, what you are doing? From the circuit diagram, so IA from the circuit diagram, I'll write it here. From circuit, you can write it as I line is given by here, this I line. I line is given by IA plus ISH. I line is given by IA plus ISH. IA plus ISH. So with the help of this, you can find the value of IA. IA is given by I line minus ISH. I line we know, but we don't know the value of IS. So that we need to find the value of ISH now. ISH is given by V divided by RSH. So whereas V is 250 and RSH is 125, so you can get ISH equals to, a second. So ISH equals to 250 divided by 125. You can get 2. So ISH is ISH is 2 amperes. Now you can get the value of IA. So IA is given by, so you can easily get the value of IA now. IA which is given by I line minus ISH. ISH you already calculated 2 amperes. I line they are given 25 amperes, so that 25 minus 2, you can get 23 amperes, that is armature current. So now we'll get the value of EB. So this EB is given by V minus IARA, whereas V is 250 volts minus IA is 23 and RA is 0.5. So you can get EB which is always less than V. So that EB is given by 250 minus IA into RA. So you can get 238.5 volts. 238.5 volts is your EB. So once after getting the value of EB now, to calculate speed, N is given by EB into 60 into A divided by 5ZP. So A is nothing but 2 now because they are given waveform. So that EB is 238.5. By substituting all this value, 238.5 into 60 into A equals to 2 divided by 5ZP. 5 they are given 0.02. Z just now calculated, that is 300 armature conductors. P they are given 4. So you can get 1192.5. 1192.5 RPM is the value of speed. Okay. So with the help of given, to find N, you should find the value of EB, whereas EB is given by V minus IARA. To find EB, you should get the value of IA, whereas IA is given by I line minus ISH. To find ISH, V by RSH, by substituting all, you can get the value of IA, that is 23 amperes. Then we get the value of EB, that is 238.5 volts. By substituting all this value, you can get the value of speed, that is 1192.5 RPM. Okay. So next what they asked you to find torque developed. You can take the screenshot, or else if you're understanding that's fine, no problem. Just you should know how to get the value of speed. So the second point, what they asked, so they asked you to find the value of torque developed. So torque developed is nothing but armature torque. TA is given by 0.1595 into IA PZ by A. They're given it is a waveform, so that A equals to 2. So you can rewrite here 0.1595, they are given 0.02. I guess just now calculated 23 amperes. P is 4. P is 4. Z just now calculated 300 divided by A is nothing but 2. You can get the value of armature torque TA. So you can get 0.159 into 5 is 0.02 into 23 into 4 into 300 divided by A equals to 2. And 43.884. 43.884 Newton meter is a torque value. Power developed, they asked. Power developed P is given by EB into IA, you can use. Or if you wanted to write another formula, P is given by armature torque into omega, whereas omega equals to 2 pi. You can write TA into 2 pi N divided by 60. You can get same answer, any one formula you can use. So whichever is you can use. EB 238.5 into IAS 23, you can get the value of power P. That is 238.5 into 23. So you can get 5485.5. 5485.5 watts. If you wanted to clarify, you can just use this also. So P equals to torque is 43.884 into 2 pi. N is 11 something you got. So just substitute the value of that 1198.5 divided by 60. You can get the same value, that is 5.4 kilowatt. So this solution, they asked it for, I think, 8 marks. So just look into the question. 8 marks. So they asked it for 8 marks, so that to find the value of speed itself, we'll be having some 4 marks, or else 4 or 5 marks, then plus 2 plus 1, or else plus 2 plus 2 can get. Okay. So next they asked 8 8 16 for 4 marks. They asked you to write the EMF equation of DC generator. For these usual notations, the notations you are getting it in a formula handbook itself. If you are having any confusions, please go through that while writing in the examination. So what are the notations? First, you have to define pi is nothing but flux per pole in Weber. So after that, you have to define the value of Z is nothing but total number of armature conductors. Once after that, then you define P is nothing but number of poles. Then we define A is nothing but number of parallel paths. So this number of parallel path, it is depending on the two types of armature winding. The first one is a lap winding, other one is wave winding. A number of parallel path A equals to 2 for wave winding and A equals to P for lap winding. That you should know. So once after defining A, then N is nothing but speed of armature in RPM. Then EG, that is nothing but EMF of generator or generated EMF, we can say it as. This is nothing but EMF per parallel path. That is nothing but EG divided by A, or else E divided by A, you can write. So once after that, now you need to get the value of flux that cut by one conductor in one revolution at the armature. That is nothing but change in flux d phi. So d phi, this flux which is depending on number of poles and flux. So that you can write d phi equals to p into phi, change in flux with respect to number of poles. Okay, so that d phi equals to p into phi Webers. This is equation number 1. Then we define dt. Time taken to complete one revolution, it takes 60 by n seconds. So once if you know d phi and dt, then you can define EMF generated per conductor according to Faraday's law of electromagnetic induction. Where there is a EMF, there is a flux. So that EMF generated per conductor is given by d phi by dt, whereas d phi is nothing but p into phi and dt is nothing but 60 divided by n. So by rewriting this, you can get p by n by 60 volts. Remember, EMF generated per conductor. So once after that, then EMF of generator is nothing but EMF per parallel path. So you just substitute EMF per parallel path. So whereas you can rewrite here, EMF of generator is nothing but this EMF generated per conductor into number of conductors in series per parallel path. So you can multiply just Z for this equation P phi n by 60 volts for EMF generated per conductor. So if you want to get EMF generated, send this conductor to the right side, it becomes multiplication, so that you can rewrite here. So P phi n Z divided by A per parallel path, EMF per parallel path. So EMF generated is P phi n Z divided by 60 per parallel path is nothing but A. So that you can rewrite P phi n by 60 into Z by A. These are not changing, so that you are writing here EZ equals to pi Z NP by 60A, whereas A equals to P for lap, A equals to 2 for wave winding. So these are the solutions for Model A 3, question number 6 of model question paper for Introduction to Electrical Engineering. So I hope you are understanding the concept, and also you can take screenshot for your reference to write in the examination. This much of explanation is more than sufficient to write in the examination, so that just go through it. And if you're having any doubts, feel free to write in a comment box. And thank you so much for watching this video. If you like this video, please do subscribe. Thank you.